Let's talk about soil sampling methods and the general cost-quality trade-offs. This isn't going to be an all-inclusive video, we're just going to hit 5 key decisions. The goal here is to understand and manage individual sections of fields where conditions are relatively consistent. Now, unlike fertilizer, soil samples don't grow crops, but they do increase efficiency, helping you stretch those inputs further. So think of it as a technology investment rather than as a line item on the fertilizer bill. First, we need to decide how to divide the field. Dividing fields into uniform grids is still the most common practice, though zones based on soil type are rising in popularity. While this is very rough, I like to use a factor of 2 to convert between zones and grids. For example, a 5-acre grid will be roughly as accurate as a 10-acre zone if that zone is based on solid agronomic data like soil type or topography. Because of all the data work involved, it is more expensive to make zones than grids, but zones are usually cheaper to sample and analyze because they're less dense. That's why sampling density is the second decision we need to make. Increasing density increases both the quality and cost because there are more samples to pull and analyze. Doubling the density doubles the lab costs and usually increases extraction costs by 20 to 60%. Quality-wise, it depends on how variable your soil is. If you have hills, lots of rain, or sandy soil, I would recommend something relatively dense. 2.5-acre grids are pretty common, as are 5 to 10-acre zones in the Midwest and 10 to 20-acre zones further north and up in Canada. Next, we need to decide how many soil cores to take and where to pull them from. Point sampling is typical throughout the Corn Belt, and it's where you pick a point, usually in the middle of the grid, and pull 6 to 8 cores from across several rows. Distributed samples are where cores are pulled from throughout the grid or zone, sometimes using an M pattern. These are more popular in Canada and the Pacific Northwest. In grids or zones smaller than 10 acres, the sample type probably isn't going to have much of an impact, but if you're doing something bigger than that, I would strongly recommend a distributed sample. Fertility samples are typically pulled from 6 to 8 inches deep. The ideal sampling depth, though, depends on how the fertilizer recommendations will be calculated, so be sure to ask your agronomist. Most fertilizer recommendations come from university studies that simply find correlations between yield and soil test values, so you want to use the same sample depth that was used in those studies. Most farmers soil sample every 4 years, though I would recommend more in lighter soils with good drainage or with really high-value crops. Spring sampling is usually more accurate and convenient than fall sampling because your soil profile changes throughout the year, and I like to know what my soil is like during that crucial time of germination. However, fall sampling is still more popular, and it's helpful to match what was done in the past so you can track the field's fertility changes over time. That's it. Hope this was helpful, but there are other factors to consider, of course, so I do recommend talking things through with an agronomist. Thanks for watching.